Okay, so in this question we have to solve a rational inequality. So we are solving a rational inequality. So first thing we're going to have to identify are critical points. So our critical points of our rational inequality are anywhere the graph could change signs. Specifically, he can change signs at zeros and vertical asymptotes. If we think about it, if we were to have a graph that would be looking something like this, we realize here that we have two zeros, and above the zero the graph is positive, and above this zero our graph is positive, which would definitely be part of this requirement. And then here, let me erase that. So here between these two zeros, our graph is negative, which means that that would not be valid. That would not fit the constraint of this inequality. So this, if we were just looking at a pictorial graph, we would say that the red portion would satisfy that inequality. However, we can also have examples of where vertical asymptotes may play into sign changes. Let's just say that we have a vertical asymptote here. So if our function was coming here and went off to positive infinity, here our graph is positive. It's above the x-axis. But now let's say it jumped down here and came from above. We realize the graph went from being positive, which I can show in red. The graph went from being positive, and then down here, that in the green portion, our graph is now negative. So at this vertical asymptote, we can also have a sign change. So we're going to find these critical points by zeros. First of all, zeros. We're going to set our numerator equal to 0, and then our vertical asymptote, so we should be getting pretty good at this, we set our denominator equal to 0. So here we have x minus 2 all over x minus 3 must be greater than or equal to 0. So first of all, I'm going to identify my 0. I'm going to set x minus 2 equal to 0, so x equals to 2. So if I'm doing a running tally of my graph, I know at 2, I'm going to cross that x-axis. At my vertical asymptote, I know that I'm going to set x minus 3 equal to 0, or x equals to 3. So I know here at 2 and then at 3, I'm going to give myself a little bit of space here. This is 2 and this is 3. I'm going to have a vertical asymptote which will run like such. So now, even though the question doesn't ask us, if I were to give you f of x, if I were to graph this guy and just tell you that he does have a horizontal asymptote, I hope now that we could recognize the degree of the numerator is equal to 1, the degree of the denominator is equal to 1. Therefore, the horizontal asymptote will be at the ratio of my leading coefficients. So the horizontal asymptote will be the line y equals to positive 1. So here at positive 1, I'm going to have a horizontal asymptote which will look something like that. So now we're going to use some deduction. Is it possible that my graph can come down here and cross like such? Is this possible my graph can do this? And I hope we recognized absolutely not. We are not going to cross along this horizontal asymptote. It's absolutely impossible. So I do expect my graph to come along here, the horizontal asymptote, and then cross at 2, and then dip down here at 3. So we know that the graph is going to look something to the left like this. But now my question to you guys, does my graph pop down like such, or does my graph come up like such? And I'm going to emphasize this point right there. Could it be my top one or could it be my bottom one? And I hope we all recognize it cannot be the bottom one because we only found 1 0. We found this 1 0. In order for it to come from the bottom and go up here and to become tangential to the horizontal asymptote, it would have to cross the x-axis again. But we don't have another 0. Therefore, this guy could not feasibly be the option of the graph. It cannot come from negative infinity and then cross the x-axis and become tangential to my horizontal asymptote. It's not allowed. Therefore, I know my graph must look something like this. So if we were to look at the graphical interpretation and we want to know where our graph of this function is positive, greater than or equal to 0. First thing I must recognize, I know that my solution can never equal to what value? And I hope we all recognize that x can never equal to 3. The reason it cannot equal to 3 is because at 3, our rational function is undefined. It doesn't exist. So no matter what happens, we can never include 3. But if we recognize where is this guy positive, I'm going to show you where he's positive in red. No, actually, I'm going to use a different color. Let me use a different color. I'll use orange. So notice in orange, he's going to be positive all the way here until -2. And we are including greater than or equal to 0, so we are going to include here at 2. Then from 2 to 3, he's not positive, he's a negative. And then from 3 all the way down to infinity, this is infinity all the way over here, he's also positive. So I could write this solution for this answer, so we could write the solution as negative infinity to a value of 2, and we would include the 2 because it's greater than or equal to 0, and at 2 we have a 0. And then we're going to have to unionize this or conjoin it with 3, but I can't include the 3 because that is where a vertical asymptote exists. It cannot exist there, and then he will extend all the way out to positive infinity. So that's the graphical means of doing this. But let's go ahead and use a more computational approach, a computational approach to determining where this guy is greater than 0. So we're going to have to go ahead and use, hopefully this, let me take a pause. Okay, we had a little glitch there, but the computer is back on track. So let me go ahead and see what this question was again. So I'll write it down here so we can all see it. It was x minus 2 over x minus 3 is greater than or equal to 0. So we're going to first of all do a sign analysis, which is a very computational approach to determining where this guy is positive or negative. So first of all, what we're going to do is we're going to line up our factors of x minus 2 and x minus 3 vertically. And then on this line here, I'm going to line up my critical points, my first critical point being 2, my next critical point being 3, and I know the signs will subdivide in this type of formation. So I'm going to take and look at x minus 2. I know that corresponds to a value of 2. Pick any value to the right of 2, 3, 4, 5, 6. Plugging all those in, we're going to get a positive, a positive, a positive, a positive. So between 2 and 3, if I pick 2.5, 2.5 minus 2 is positive, so this will be positive here. To the right of 3, picking 4, 4 minus 2 is positive, it will be positive here. To the left of 2, I'm going to pick a value like 0. 0 minus 2 is negative. So I know x minus 2 is negative to the left of 2, positive between 2 and 3, and then positive to the right of 3. X minus 3 corresponds to a value of 3. Pick a value to the right of 3 like 4. 4 minus 3 is a positive value, it's a positive 1. Between 2 and 3, I pick 2.5. 2.5 minus 3 is going to be a negative. And then to the left of 2, like 0, picking 0. 0 minus 3 is also negative. Therefore, I know I can get these values because I'm dividing x minus 2 by x minus 3. I know a negative divided by a negative, or a negative times a negative, is a positive. This guy is a positive times a negative, which is also a negative. Positive times a positive is also a positive. So if I look at this, notice it's positive, negative, and positive. So I'm going to try to select this graph. Yeah, that's not working. So I'm just going to leave it there. So I guess my computer's not liking this very much. So so notice here, so I'll just delete this thing. Let me draw it back in. So notice it is going all the way down like such. So notice from negative infinity to 2, my graph is positive. Just like I notice here, from negative infinity until 2, my graph is positive. From 2 to 3, my graph is negative. And look, between 2 and 3, my graph is below the x-axis, so it's negative. And then from 3 to infinity, my graph is positive, and I also expect my graph to be positive. So notice here, if I want to find out where my graph is greater than or equal to 0, knowing that I cannot include 3 because 3 is not a part of my domain, I know he's positive between negative infinity and 2, including 2, and then we're going to conjoin 3 to positive infinity, and that is going to be greater than or equal to 0. Let's say I asked where this graph was less than or equal to 0. We know this graph would be less than or equal to 0 in this area right here between negative 2 and 3. So I would include 2 because it's less than or equal to. However, I would not include 3 even though it's less than or equal to, because at 3 we have a vertical asymptote. So do practice these rational inequalities because they can be very interesting and challenging. However, through some good practice, they shouldn't be that tough.